Hello all. In the series of covering SAT topics, this is our 15th video where we will learn about properties of triangles. So what we have to learn in properties of triangle, let's see. We will start with types of triangles. So first on the basis of sides. On the basis of sides. First, equilateral triangle. Equilateral triangle where all three sides of a triangle are equal, as well as angles are also equal. Then isosceles triangle. In this one, two sides are equal, whereas one side is not equal to the other two sides. Number 3, that is scalene triangle, where all three sides are different. Now let's talk about some properties of equilateral, isosceles and scalene triangle. So in equilateral triangle, as I said, all three sides are equal, all three angles are equal, as well as if you draw perpendicular line in an equilateral triangle, that means altitude of the equilateral triangle, those are also equal. And that in equilateral triangle and isosceles triangle, if we draw any altitude or even angle bisector, that will be same for from the equal sides, so that will perpendicularly bisects the base both in equilateral and isosceles triangle, given that these two sides are equal. But there is no such case in scalene triangle. This is a basic property which is widely used for other topics in triangle. Now on the basis of angles. On the basis of angles also we are having three types of triangle. First triangle is acute angle triangle. Acute angle triangle. Number 2, right triangle. And number 3, obtuse angle triangle. So what is meant by all three? So in acute angle triangle, all angles will be less than 90 degree and greater than 0 degree. In right triangle, one angle is 90 degree. In obtuse angle triangle, one angle is greater than 90 degree. Greater than 90 degree. We don't need to say less than 180 degree because we know that sum of all three angles is 180 degree. So greater than 90 degree and less than 180 degree. So these are the types of triangles on the basis of angles and on the basis of sides. Now we'll see some properties of right triangle. So suppose we are having a right triangle. Suppose this is the right triangle we are having, where we know that the side opposite to right angle is called as hypotenuse and other two are just legs. So suppose this is A, this is B, and suppose hypotenuse is C. Then there is a theorem called as Pythagorean theorem that relates the three sides of the right angle triangle, which says A square plus B square will be equal to C square. That means sum of square of the two legs is equal to the square of the hypotenuse. Now, special right angle triangle. Special right triangle. We have to know about the relationship in special right angle triangle. So suppose there is a right angle triangle. We will talk about two types of triangle here. So let's draw the two types of triangle, where one triangle will be 45, 45, 90 degree triangle, whereas the other triangle will be 30, 60, 90 degree triangle. So suppose this is 45, 45, 90, that means these two angles are 45 degrees, whereas this is 90 degree. Now let's show one more triangle where we will be having 30, 60, 90 angle. So it's like this. Suppose this is the triangle we are having. This angle is 30 degree, this angle is 60 degree, and this angle is 90 degree. Then we always have to remember that we know that these sides are A, B, C. So in a right angle triangle where two angles are 45 degree, that means this is isosceles right angle triangle. because two angles are equal, that means these two sides will also be equal. So we can say A is equal to B. And always remember, hypotenuse is root 2 times these equal legs. So we can say C is equal to root 2 times of A or B, whatever we can say. So these two sides are equal, and hypotenuse is always root 2 times the leg of the right angle triangle. That is the leg of this special 45, 45, 90 degree triangle. That is the relationship in 45, 45, 90 degree triangle. If we talk about this 30, 60, 90 triangle, then suppose this we are having x, then the hypotenuse, see, this is the shorter side. So hypotenuse is always twice the shorter side, whereas hypotenuse is twice the shorter leg, whereas the longer leg is root 3 times the shorter leg. So we can write here, can simply write a leg. So hypotenuse, shorter leg means the leg which is facing 30 degree angle, right? So hypotenuse is always twice the shorter leg, and you always have to know here that longer leg is root 3 times the shorter leg. So we have to remember these results for these type of special right triangles. And it can also be given that hypotenuse is given and you need to find these two sides. So you have to remember the relationship, and then we can use this as an equation to solve. Now moving on to next topic, we have to learn about similarity of triangles. So there won't be any question to prove similarity or direct question related to similarity, but we will be having indirect questions related to similarity. That's why we need to know. So as we know, the types of criteria for similarity of triangle is RSSS, where sides of one triangle are proportional to corresponding sides of another triangle. Then number 2, that is SAS. That means here we can say our two sides of one triangle are proportional to two sides of another triangle, whereas the angle between them are congruent. Then number 3 is AA. If any two angles of a triangle are equal to any two angles of another triangle, then the both triangles will be similar by AA criteria. Number 4, LH. So if hypotenuse and leg are proportional in any right angle triangle, then we will say that those two right triangles are similar. So mostly in questions we will be using the property of similarity of triangle, basically the property that all three sides of one triangle are proportional to the corresponding sides of another triangle if the triangles are similar. This one will be used like in this question. What it says, in the accompanying figure, AB is parallel to CD. If AB is equal to 40, CD equal to 16, BC equal to 49. So what is the length of B? So first of all, here it's given that AB is parallel to CD. So before using the property of similarity of triangle, first we need to know whether these two triangles here are similar or not. So you can see there is nothing written in the question that we have to use which property. So you will have to identify by yourself that which property you are going to use. So here we will be using similarity. So how we can use? So angle, since AB is proportional to CD, so we can say that angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. And also angle 3 is congruent to angle 4. Both of these are congruent because these are alternate interior angles. So now we can say that these two triangles are similar by AA criteria, because two angles of one triangle are congruent to two angles of another triangle. Now what we will be doing here, that this is very important in writing the statement of the similarity. So one triangle we can write in any order, like we can write A, B, E. This is the sign of similarity. So ABE, triangle ABE is similar to, now we will write according to the congruency of the angles or proportionality of the sides, whatever we will be getting. So here we know that this angle A is congruent to angle D. So we'll first write angle D. That was D as that is the first vertex we'll be writing. Then we know that C is the vertex which is equal to B, because here the second is B. So that is B. Oh, sorry, C. And then E we will be writing. So first we need to just identify the order which we will be writing, and the same order we will be following for both triangles while writing the similarity. Because why we are saying this? Because when we will be writing the proportionality of the sides, that will help very much. So we don't need to see the figure now. We can simply write AB is proportional to DC. That means AB over DC will be equal to BE over C, and that is equal to AE over DE. So from here, what we can say, as you can see in the question, it is given AB is given, CD is given, BC is given. So AB and CD is given. That means first proportionality statement, and then BC is given. BC is given, but BC is not we are using here, but we are using BE and EC. That is the second. So we can just focus on these two, because we are having equal sign between them. So even if we are taking these two, then we can write an equation. So AB we are having AB, that is 40 divided by CD, that is 16, is equal to BE. Let's say BE is X, then that will become X divided by, because BE has been asked, so we have taken BE as X. So X divided by CE. CE, that will be total length BC, which is given as 49 minus X, right? Now, what we can do here, we can multiply both the sides, but before that, we can simplify this. Both are cancelled from 8, so 8 times 5. So 5 over 2 is equal to X over 49 minus X. On cross multiplication, we will be getting 5 times of 49 minus X is equal to 2 times of X. So this implies that 5 times of 49, that is 245 minus 5X is equal to 2X. This implies that 245, we can add 5X to both the sides. So 2X plus 5X, we will be getting 7X. So X will be equal to 245 over 7 on dividing both the sides by 7. So we are getting 35. That means the length of BE will be equal to 35. So that's the answer. This is how we can solve the questions using our property of the similarity of triangles. Now moving on to next topic, inequalities in a triangle. So what we have to learn in inequalities in a triangle is, always remember that side larger angle faces the longer leg. Suppose there is a triangle, we are having A, B, C. So we can say that if we are saying that if angle A is less than angle B is less than angle C, that means we are saying that angle C is the largest one. That means AB will be the largest one. Figure is not drawn appropriately, but you need to understand this, that C is the largest angle. That means the side facing the largest angle will be the longest side. So we can say here the smallest angle will be the shortest side. That means BC. So we can say here that BC, the side facing angle A, will be the shortest side. Then the side facing the angle B will be the second shortest, because angle B is in the second. That means we can say AC, and that is less than longest side, which is BC. Which is AB, side facing the angle C, AB. So this is the inequality in a triangle which we have to remember. One more inequality is there, that is side length restriction. So according to side length restriction, we can say that sum of two sides of a triangle is always greater than the third side. That means we can say, suppose three sides we are having A, B, C. So A plus B will always be greater than C. Similarly, B plus C will always be greater than A. and C plus A will always be greater than B. So these two types of inequalities in a triangle which we have to remember. Let's see a question from this topic. So this is the question which says that if 3, 8 and x represents the lengths of the sides of a triangle, how many integer values of x are? So as we discussed in the side length restriction, it's not like that there can be any side of, I mean, any length of side. So we'll use this property and we will say that 3 plus 8 should always be greater than. That means from here we are getting x always less than 11. Then 3 plus x should always be greater than 8. So from here we are getting x greater than 5 on subtracting 3 from both the sides. And 8 plus x will always be greater than 3. So from here we are getting x greater than negative 5. On combining these three from above inequalities, on combining these three inequalities, we can say that x should be greater than 5 but less than 11. So let's see, it's saying that how many integer values of for x are possible. So x can be 6, 7, 8, 9 or 10. So these are the integer values which are possible for the side length of this triangle. So this type of questions can be asked from this topic. So that's all in properties of triangles. We will meet again in the next video. Thank you.